in the domain, for every measurable set. So suppose mu is a probability measure invariant under F. Okay? And suppose you have X contained in M with full probability. Okay? I claim that F minus 1 of X has full probability because it's the same. Well, what is F minus 1 of X? It's the set of points that whose image is in X. Okay? Then I claim that the measure of the intersection is 1. It's still 1. And this is much nicer. This is the set of points that are in X and such that the image is also in X. Okay? Why is this true? I don't want to presume that you have lots of familiarity with measures, but it goes like this. You have a full measure set, X, which means that what is here outside is measure 0. Then you have another full measure set, F minus 1 of X, that's what is outside is measure 0. You take the intersection. So you take the whole thing here. What is left outside is the union of a set of measure 0 with another set of measure 0. Okay? Now, once you play this game once, you can play it any number of times, and you conclude that mu of the intersection of F minus n of X, n from 1 to infinity, has measure 1. Okay? Because this property about the measure of the union being the sum of the measures is for countable families. Okay? The complement of this is a union of sets of measure 0. Is a union of sets with measure 0. Okay? Now you call this set here Y. This is, sorry?
In the intersection?
From starting from 0 to infinite, yes. Yes. It starts in X and never leaves X. Never, 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 ever leaves X. Okay? So just a set of points whose orbits remain completely inside. So then you call this set, this intersection, you call it Y. Y is this intersection. Okay? And now I claim that f of y is contained in y. And this is obvious. Because y is the set of points whose iterates will remain in X forever. If that is true for a given point, it is true for the image. Okay? So given any full measure set, one can find another full measure set that is invariant. And that's why I don't care. I mean, I can always choose M0 in such a way that if X is in M0, f of X is also in M0. Okay? Did you like the answer? Então eu tenho uma pergunta para você. Agora encontra um Z Now you find Z, exercise. Find Z with full measure such that F improve what I did. Not only you can I'm not sure what I want. Maybe A, maybe B. You can choose which statement you prefer. But with equality. Okay? Okay, we stop here. By the way, a little bit of commercial advertisement. For those that are not so familiar with this measure theory, there's my book. So if you go to this address, then there's an introductory book in ergodic theory that includes a chapter on measure theory. Everything I said is in the book, and it's in Portuguese.